Hi, how's it going? I'm Old Doc Charles, and this is some rubbish on systems engineering. We're going to start off with part one. I'm going to talk about systems. Well, what's a system? And really, what the fuck's it got to do with railways? And it's always traditional to include an introduction. So here's an introduction. This is all the shit I'm going to talk about. I talk about the system railway. To do that, first thing you need to understand is exactly what's a system. So, yeah, what's a system? So, in its simplest terms, a system is just a thing that does a thing within an environment. And the environment has everything the system needs, and nothing can enter the environment, and nothing can leave the environment. Okay, so what's a system? Well, systems don't, exist in isolation, but in order for a system to exist, it needs a reason. So you need, a thing that needs doing. You need some demand. All right, and a demand can be, there can be a demand there that nobody's seen, and all of a sudden you look, you think, oh God, there's demand there. Let's build a system. Or it could be that the demand, you can create demand. 45 years ago, there was some bloke sitting around in an office saying, it'd be really nice if you could have a telephone that you didn't have to connect to wires, that you could just carry around with you. And, today we have our, phones, mobile phones and all that crap, right? So you can create a demand, or the demand can already exist. So that's what we build the system for. To do that thing, or make that thing, do that whatever. But we can't just, have a demand. We need other things to help us do that thing, and these are called resources. So you've got things like people and equipment and, money, very important, and things like that. But we just can't, go out and, do whatever the hell we like. So, we have these things put upon us called constraints. And it's constraints that actually, cause lots of problems. For example, you can't employ children anymore. You have to pay a minimum wage. You have to have health and safety. If you didn't need all that stuff, then you could, build your system much easier. So these are the constraints that we have upon us. And then that results in, there you go, ta-da, yeah, the thing is done, whatever, so there's the output. But the system doesn't really exist, again, in isolation, because there are many other systems that interface with our system. Yeah, and these interfaces basically connect to different constraints and resources and, demands and outputs and things like that. And the interfaces, they can be physical. For example, stations, they need to be connected up to the sewers and all that, so you need pipes and, physical things. Or they can be regulatory. There's a multitude of laws and standards and regulations, that you have to adhere to, and if you don't, then you end up fined and in jail and, maybe worse. Or they could be contractual, contracts between companies and people, and to provide resources and services and all sorts of crap like that there. Yeah, so, and in the system railway, there's literally thousands of interfaces. Interfaces also give rise to a thing we call requirements, and we'll talk about them next. Requirements. Right, so requirements tell us things that we have to do or things that we mustn't do. When you write requirements, they have to be specific. You have to give a value, a number. For example, the illumination in the toilet shall be between 150 and 250 lux, which is the measure of light. So the words must and shall must be used. Yeah, don't use words like may or should or anything like that. Requirements are hideously boring to read. They are not literature. We get our requirements from our stakeholders. And I'm going to now talk about what the hell stakeholders are. Stakeholders are not just angry villagers. A stakeholder is any person or organization that has anything to do with the system. Stakeholders can be directly connected with the system. For example, all your employees, the suppliers, people you buy your crap from, contractors, the customers, et cetera, the fucking government. They can also be anybody that's actually affected by the system. This is where we have the angry villagers and other people that live, close to where we're going to build the railway. Environmentalists, so Greenpeace and, the Environment Agency and all these sort of other people. Heritage, the National Trust and English Heritage. If you're going to build a railway next to one of their old castles, they're afraid the vibrations from the trains might cause it to, collapse. Third parties, including people like, vandals and trespassers. It's really important to identify your stakeholders really early on, because if one turns up later on, you could be screwed. What we need is a process to manage all these stakeholders and their requirements in order to build a system that meets the demand. And I'll talk about one of these methods, next. One method is what they call the V process. Essentially, are a set of steps that covers the system from its inception to its eventual dismantling at the end of its life. The V process ensures that the system is being built correctly by undertaking what we call verification. And it also ensures that the correct system is being built by undertaking what we call validation. The V process is very thorough, but the V process very inflexible and also, very expensive. You have to have so many meetings, order all that tea and biscuits. And of course, other system design processes are available. The waterfall model, an incremental model, a spiral model, and there are other. I'm going to talk next about the V process, what goes on in that. Behold, the V process, shaped like a V because it saves space on the page. There's two sides to the V process, a left side and a right side. I'm going to go over the left side first. The first thing is you've got the system aim, the demand. Once you have your demand, you then go out and find your stakeholders. Then what you do is you look back and see that you've got all the stakeholders that have anything to do with the system demand. Once you've done that, you can then go on and get your requirements from the stakeholders. Then once you've done that, you can then do a functional decomposition, and that's essentially where you take your requirements and you think, right, what kind of shit can we build in order to do this requirement? Once you've done that, then you can finally design the system, and then once you've designed the system, you can then break out the bulldozers and all that crap and actually build the thing. As you come down the left side, as you do each step, you always check back to the previous step to make sure you haven't missed anything. And this is what we call the verification. Now that we've gone down the left side, we now go up the right side. As you build crap, you test it. You look across and you go, oh yeah, okay, does it work as it was designed? And this is the validation part. So once you've tested all your bits, so you then put them all together into your system. And this is called integration. Once, we've integrated, we put it all together, we then do a verification, make sure that got all the requirements and the system is ready to go. And then that's it, take it out and we start testing and that, make sure everything works and you don't have any surprises. Once you've done that and it's passed all the tests, you can then operate it over its life and then, dispose of it in an environmentally friendly way at the end. Now, all this looking across is what we call the validation. Yeah, so that's it for the V process. Okay, so now that we know kind of what systems are and how they're made and how to make them and all that, let's sort of talk about something more practical. So we'll start with basically transportation as a system. So stuff Ned's moving, and in order to move that stuff, and it could be freight, it could be people have to go to work and commuting and going shopping and big on holiday and shit like that. And so then we've got the constraints and the resources, and there you go, ta-da, at the end, the stuff has been moved. Now, how do we know? I mean, that's just moving stuff. So moving stuff by any way, there is to move. So let's just take a look inside that. And we have all the different ways that you can move stuff. So, first, you can move stuff by road. So you can, fill lorries with your stuff from, Amazon vans and, Eddie Stobart lorries and all that sort of crap. And, people move, they walk, they ride on their bike, they scooters and all sorts of other weird fucking things they have now. And, cars and motorcycles and SUVs and, things like that, things that travel on the road. Another popular method of moving stuff is by ship. So you can put all your crap on a boat. So all your ice shit and that, comes from China on a boat. And, people can go on boats. There's ferries and cruise ships and sort of shit like that. You can put stuff in a pipeline. Yeah, these are usually liquids, So, for example, in the UK, aviation fuel is distributed to the airports in pipelines. Yeah, that's why you don't see loads of aircraft fuel tanker lorries on the road. Pipe is really, fluids or, unless it's Futurama and they've got that pipe that you go into and that sucks you off. You can fly. We learned to fly 120 years ago or thereabouts. And, you can move stuff in an airplane, air freight and all that shit, and UPS and small packages and blah, blah, blah. And, of course, people fly all the time. You can beam me up, Scotty, except that hasn't been invented yet. And it's science fiction anyway, isn't it? And, of course, then there's moving stuff by rail. How do you know which of these ways to move stuff are you going to choose? Well, this all depends, of course, on the requirements. And it has a lot to do with, distance and time and, it's very complicated, calculations that you do to determine which is the best. But it's really the functions, and it's based on the requirements. So that means you could even have a thing like, system trebuchet. If it meets the requirements, then that's it really. So the thing about rail, which is kind of the focus of what I'm going to go on about. If, we look inside, what we see is more boxes. I mean, it's worse than them bloody Russian dolls. So what are the systems that are needed inside of the system railway in order to make it complete and work? The first thing, is obviously the management. So you need to manage the whole railway. There's all that paperwork. There's, getting staff and hiring and, firing people and, dealing with revenue and general management of the railway. And then the railway, you can't just run trains whenever you like. So you have to operate the railway. That's, the timetabling and all that sort of stuff, which is, in a complex network, timetabling can be very, very, difficult, right? And, it's operating, it's also rostering staff and all that sort of crap. Then we have what we call the guide and support. Well, that's, the infrastructure. Yeah, 'cause that's what the infrastructure does. It guides the trains along, because trains don't steer. And it also supports the loads and the traction and braking forces and all that sort of stuff. Then we have what we call carry and protect. Yeah, so that's the rolling stock. That's, that's the thing that actually carries, whatever it is you're moving. And it protects it from the weather and, somewhat in the event of a derailment. The rolling stock doesn't just, move by itself. It needs to be propelled, and it needs to brake. So that's the traction and the braking system, which is the motors and the control and the brakes and all that sort of shit. And then we have control. The railway needs to be controlled. You can't just let trains go whenever they want. So you've got the control system, the signaling, and all that sort of stuff in order to make sure that the trains don't crash into each other. And finally, we've got all this crap, needs maintenance. Yeah, so you've got to maintain. You've got to maintain the track, the infrastructure. You've got to maintain the rolling stock. You've got to maintain the signaling. And you basically have to maintain sort of all this crap. And that's what maintenance is for. So, there you have it. The system railway. It's not what it is. It's what it does that's important. As I go on more and talk about these individual subsystems, and I go into them, you'll find that they're full of even more boxes. So, get used to the box. You'll be seeing it a lot. And there you have it. It's, again, traditional to basically tell you what it is I talked about. And so here's that. So if you're interested. And yeah, that's it. That wraps it up for this first lecture. I really don't know what I'm going to do next. We'll see how it goes. And thanks for, putting up with me till now. I think that need be all.
Introducing System Trebuchet, a revolution in low demand, short distance transport. System Trebuchet is manufactured from environmentally friendly, renewable materials. System Trebuchet does not require an external power source, resulting in a minimal carbon footprint. System Trebuchet is good for the economy and creates jobs. System Trebuchet also considers the traveling public. Luxurious first-class seating is provided at all installations. System Trebuchet is easy to ride. Passengers simply sit in the luxurious first-class seat, and dons the departure harness. At the departure time, the passenger is smoothly accelerated out of the departure lounge into a precisely calculated trajectory that brings them in for the perfect landing, a short distance from their destination. System Trebuchet needs minimal maintenance. A tub of lard for lubrication is all that's required. System Trebuchet can easily be relocated to meet changes in demand. Remember, For all your low-demand, short-distance transport needs, choose System Trebuchet. System Trebuchet, beware of imitations, accept no substitutes.